week 2 of measurement, we're going to start digging into the metric system. And I kind of gave you a preview of this last week, but the metric system is the system that is used almost everywhere else in the world other than the United States. And the metric system is really cool because if you understand place value, then you understand the metric system. It's not like the customary system where, sometimes 12 inches equals a foot, but then 16 ounces equals a pound, right? The units of how the units relate to each other are not consistent from one unit to the next. That's not true in the metric system. So I want us to start by thinking about place value, and then I'll show you how this all relates into the metric system. So we know that when we have our place value, we know that, from our ones to our tens, our ones are 10 times greater, right? So 1 times 10 will give you 10, and that's 110, right? So tens are 1 times greater than 10. As we continue on, it's the same for tens to hundreds, right? Hundreds are 10 times greater than tens, and thousands are 10 times greater than hundreds. And I've abbreviated here, but you know what those words should be, right? If we think moving on the other side of our decimal point, right, because we would have a decimal point right here, from ones to tenths, we know that ones are 10 times greater than tenths, or tenths are 1/10 of 1, right? How many tenths does it take? It takes 10 tenths to make 1/1, right? And the same thing goes for tenths to hundredths. Tenths are 1/10 of a hundredths, right? So we can see that this pattern for place value continues throughout each place value position that we have. Well, let me show you how this relates to the metric system now. For the metric system, we've got that phrase, if you remember, King Henry doesn't usually drink chocolate milk. That can help us remember the prefixes of the metric system. So king is for kilo, Henry is for hecto, King Henry doesn't is for deca, usually is for units, and we're going to kind of leave that blank right now because our units can swap out for the metric system. So our units might be meters if we're measuring distance. It might be liters if we're measuring liquid volume, and it could be grams if we're measuring something's mass or its weight. Okay, then we keep going. So King Henry doesn't, U for units, doesn't usually drink for deci, chocolate for centi, and those probably starting to sound familiar to you, and then milk, milli for milk. Okay, now let's think about how these all relate to each other. Just like in our place value system, when we go from this general unit, meter, to deca, so going from meter to decameter, decameters are 10 times greater than meters. Similarly, decameters to hectometers. Hectometers are 10 times greater than what came before it, which is a decameter. And lastly, kilometers are 10 times greater than what came before it, which in this case is hectometers. This works the same way from the beginning of our prefixes here. So millimeters to centimeters to decimeters. If we want to work the opposite way, if we want to think, okay, well, how do meters and decimeters relate to each other? Well, a decimeter is 1/10 of a meter. It takes 10 decimeters to create a meter. Same thing for centimeters to decimeters. You might be thinking, okay, well, how many centimeters are in a decimeter? It takes 10 to make 1 decimeter. And so what you are starting to notice, right, is this common way that each unit relates to each other. So a kilometer, a hectometer, a decameter, a decimeter, a centimeter, a millimeter, it doesn't matter what it is. They're all based on that base 10 system, just like in our place value. system. So let's think about some examples now. So let's say I'm thinking about 1 meter, and I want to know how many centimeters that is. You guys probably already know this one. That's why I'm using this one to prove it to you, right? So you know that in 1 meter, there's 100 centimeters. Well, now look at this chart and let's prove it. Let's think about, from meters, how many positions am I moving over to get to centimeters, right? If I want to get to centimeters, I'm moving 2 positions. If I multiply 10 by 10, right, that's 100. So how many centimeters would be in a meter? That's 100 centimeters, right? We can use the same thinking to think about how many millimeters are in a meter as well, right? I'm thinking, how many positions am I moving to get from millimeters to meters? And that would be 3 positions, right? So 10 times 10 times 10, you know that would be 1,000, right? So there's 1,000 millimeters in a meter. Well, what about this word that we probably don't use all that much, decimeters? How many meters are in a decimeter? Well, we look at its position, it's 1 position away from meters, right? So we know that it would take 10 decimeters to make a meter. Now, let's think about the other side of our units. We're thinking bigger than a meter, right? So all of these are less than a meter. All of these are going to be greater than a meter. So if we're thinking, okay, well, a meter, how does a decameter relate to a meter? And that's abbreviated DAM. How does a decameter relate to a meter? Well, I know a decameter is 10 times greater than a meter. So there must be 10 meters in 1 decameter. So that means a meter is 1/10 of a decameter. Let's think about a hectometer. I'm wondering how many meters are in a hectometer, which is abbreviated HM. I know that I can use this idea of place value, right? And I'm seeing that it's 2 positions away. So a meter, there's 100 meters in a hectometer, which means 1 meter is 1/100th of a hectometer. And lastly, a kilometer. I'm wondering, okay, how does a meter and a kilometer relate to each other? I see that it's 3 positions, so that's 10 times 10 times 10. That's 1,000. So I know there's 1,000 meters in a kilometer, which means that 1 meter is 1/1000th of a kilometer. So I think maybe we're starting to understand how these units all relate to each other. I want us to take a look at an example that's something other than the number 1, okay? So let's think about 65 centimeters. And let's say that we want to know how we could think of that in meters, okay? 65 centimeters, how could we use that same measure, that same distance, right? Because meters measures distance, and speak about it in the regards to meters. Well, think to yourself, how many centimeters are in a meter? And you should know, you should either be thinking back to our table like this, or you might have looked at your reference sheet, or maybe you just know this one, right? We know that there's 100 centimeters in a meter. So we're saying, okay, we've got 65 out of 100 centimeters, right, in a meter. So we could say this is 65/100 meters. We could also say, because you know how to do this, we could also write this as a decimal, right? Because we've written this number as a fraction over 100, we know that we would say 65/100 if we've said that fraction out loud. So we could also write that as the decimal and say 65/100 written out in decimal form. Let's try another one. Let's think of 2 decimeters, which is abbreviated DM, and let's say we want to think about that in terms of meters. So if we're thinking about decimeters, let's go back to our table here, or our chart. A decimeter is 1/10 of a meter, right? But I know that I have 2 decimeters, right? So if I've got 2 decimeters, so 1 decimeter is 1/10 of a meter. If I've got 2, I've got 2 of those, right? So 2 decimeters then would be 2/10 of a meter. So I could write that as 2/10, or I could write that as 2/10 in decimal form. Both are correct. The cool thing about the metric system is that you're able to easily change between this written form, fraction form, and decimal form very quickly and fluidly because it's based on that place value understanding that we already have. Let's think about just one more example. Let's think about 3 centimeters. Thinking about how many millimeters that would be. Right? I know millimeters are smaller than centimeters, so I want to keep that in my mind as I'm thinking about how to go about this problem. Now I'm thinking, if I think back to my chart, I know I have decimeters, then centimeters, and then millimeters, right? So centimeters and millimeters, they're neighbors. They're right next to each other in the metric system. So that means that they're only different by a factor of 10, right? So I know that within each 1 centimeter, I've got 10 millimeters. So if I have 1 centimeter, there are 10 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 millimeters. So if I have 3 centimeters, I know that each one would have 10 in it, and 3 times 10 would be 30, right? So, my friends, I want you to keep these ideas in mind as you're thinking about how the metric system works, keeping in mind place value and how we can relate fractions and decimals to each other. I know it's a little bit different than than the customary system, but the metric system is pretty cool and it's really powerful because it is based on that place value that we're all so familiar with. So your job today is really just to become more comfortable with using the unit meters, right, in the metric system. So we're thinking about length. Tomorrow we'll take a little bit closer look at liters and grams, but today we're just focusing on meters and becoming comfortable with how kilo, hecto, decameters, decimeters, centimeters, millimeters, how those all relate to each other. Awesome job. Thanks for tuning in, and I can't wait to see some of your awesome work that you're going to be sharing. Thanks, guys.